Now we are going to solve questions in this video. You have on the board here 2 questions. I'm going to be fast at solving that. You will recall that in the previous videos I stated that for homogeneous second order ordinary differential equation, all you need to do is to know how to solve your quadratic equation, okay? So we're pretty going to be fast. Now the first question, we're going to find the general solution of the equation. Now let us read this together because this is another form of representing a differential equation. This means second derivative. The D there represents derivative of the variable y plus 3 times first derivative of the variable y plus 2 times y equal to 0. So for that first question, we can write it as d2y, that is second derivative of y, then plus 3 times first derivative of y, then plus 2y equal to 0. We're going to get our auxiliary equation, okay, auxiliary equation, let's get it out. I have abbreviated the auxiliary, okay. So the auxiliary equation from here, the coefficient here is 1, is that not so? The 2y was the squared x, now represent it with m squared, carrying coefficient of 1 plus 3 times dy over dx will be n raised to power 1, and then plus 2. There is no derivative here, so even if you're putting n, it will be raised to power 0, which is still going to give you what? 2. Is that okay? So I'll just extract the coefficient of that y, then make it equal to 0. We shall now solve this quadratic equation. And of course, from here, GMAS 41, we don't solve quadratic equation as per doing our full factorization. All you need to do is get the factors of this quadratic equation, change their signs, and divide by the coefficient of the term bearing square. You've gotten the roots. So let's look at this quadratic equation. It's factorizable. Okay, the factors that will solve this problem is 1 plus 1 and plus 2. These are the 2 factors that will solve this problem, because if you multiply 1 and 2, you get this plus 2, and if you add plus 1 to plus 2, you get what? Plus 3. Remember, you were urged to learn how to solve your quadratic equation, both by factorization and the formula method, as well as maybe using complementary square. So this could be factorized, and we are factorizing now. The factors are plus 1 and plus 2. So what would we now do to get the roots? So we have the roots. There are these things right on the board. It's a waste of time. But let's just do that. Now the roots of the equation m1 will be equal to, we'll change this sign. This is plus 1, so we'll change it to minus 1 and divide it by the coefficient of m squared. If you divide it by 1, you still get minus 1. Then we go for m2. Change the sign here. You get minus 2 divided by the coefficient of m squared, which is 1. Minus 2 over 1 will still give us minus 2. We've gotten the root of the equation. Please take note, there is no rule that m1 must be this and m2 must be this. Okay, m1 could have been minus 2 and m2 could have been minus 1, alright? You commit no crime. Now, if you look at these roots, these are real and unequal roots. It implies that the general solution to this homogeneous second order ordinary differential equation will be y equal to a exponential m1x plus b exponential m2x. Of course, if you substitute, our result or general solution will now be a exponential m1 is minus 1. Minus 1 times x will give us minus x. And then plus b exponential m2 is minus 2. Minus 2 times x will give us minus 2x. And of course, we have obtained our solution. So I'll write my answer. Now this is solution to number 1, okay? So let us look at solution to number 2. So that number 2, this is y prime prime plus 6y prime plus 9y equal to 0. This means the 2y dx squared, so I will extract the auxiliary equation. Let me bring it out first. Y prime prime plus 6y prime plus 9y equal to 0. Okay, now the auxiliary equation is going to be, this is m squared, the coefficient is y, then plus 6m plus 9 equal to 0. Once again, observe that this can factorize. Now the factors are plus 3 and plus 3. Because if you multiply plus 3, you get plus 9. If you add plus 3, you get plus 6. And so we're going to get the roots of the equation. Roots are going to be m1 equal to minus 3 and then m2 equal to minus 3. It implies that the solution is going to be y equal to a plus bx exponential mx. Take note that the roots of the equation are equal. So this is the solution that will work. And then y is equal to a plus bx, then exponential n, which is minus 3x. Take note that this result could have been ax plus b, okay? Could have been ax plus b, then times exponential minus 3x. And that's how we're done with the solution of this. I haven't wasted time on this, take note, okay? I haven't wasted time. You don't need to write all these factors, roots, and have them. You can actually work them out and get a result. In this video, we have a question to look at. Here we are to obtain the general solution of the DE, second derivative of y plus 4 times first derivative of y plus 9y equal to 0. Now to solve this, let me rewrite it as d2y over d squared x plus 4 times dy over dx plus 9y equal to 0. Quickly, we are going to seek for the auxiliary equation. Is that so? And the auxiliary equation from here is m squared. The coefficient of this second derivative is 1, then plus 4 times m, representing this first derivative, then plus 9. There is no derivative here, equal to 0. If you look at this auxiliary equation, can it factorize? Are there any two numbers which are factors of 9, which if you add them, you get 4? There is no such factors, alright? So you cannot factorize this auxiliary equation. Hence, you can solve it either using complementary square method or quadratic formula. But you know what? I'm going to expose you to a secret. Is that okay? Now that secret, you can use it to solve a problem like this and obtain your solution quickly. But before we move on to my exposing you to this secret, take note that even without solving this question already, I know that the general solution to this problem is that, which is y equal to exponential alpha x, open brackets, a cos beta x plus b sine beta x. How did I know that that is the solution to this? Of course, because this auxiliary equation cannot factorize and it contains the 3 terms. So you see how I've been able to at least know what the general solution will be like. So I will now quickly solve this and obtain my alpha and what? Beta. And like I said, I'm going to show you a secret. Are you ready for that? Now get your pen, get your book, and then watch what we do on the board. The secret comes from completing the square method. You know that to complete a square for this, you're going to transfer the constant term to the right hand side. So if 9 is moved, it's going to give you minus 9 on the right hand side. Now in solving complete the square method, what are you expected to do? You're expected to find half of the coefficient of this n. That is half of the coefficient of the term, which is raised to power 1. Are you following? And here, that coefficient is 4. Half of it is what? 2. Because half of that 4 is like 1 over 2 times 4. So that 1 over 2 times 4 will give us what? 2. Now what do you do with this 2? You are meant to square it, add it to the left, add it to the right. But I will not go through all those protocols. Now watch. Because I'm meant to square this 2 and add it to this left hand side. This n is carrying square also. So I'm going to write n. The half of that coefficient that I found, which is 2, I will add it, okay, and then square it. Take note, if this is minus, means that you're going to put minus here, then square it. Is that okay? That will now be equal to minus 9. Take note, that half of the coefficient of n here is meant to be squared before adding. But I told you on the left hand side, I'm not going to square it to get 4. But on the right hand side, that 2 is going to be squared and then added, so that this will give us what? Minus 9 plus 4. Now watch this again. We have n plus 2 squared equal to, if you work out this, you get minus what? Minus 5. Do you know that if you take square root of both sides to remove this square, this will give us square root of what? Minus 5. To tell us that that part is going to be what? The imaginary part. Now watch. This is going to give us n plus 2 equal to square root of minus 5. So this part will now give us the imaginary part. The imaginary part. Imaginary. Okay? So imaginary part of our solution. That is where we'll get our beta from. and then this part will give us the real part. This is where we get our alpha. So you get alpha from here, you get beta from here. Is that okay? Now watch. At this point, I will change the sign. This represents our alpha now, but I will change this sign, this plus. Change it. Come here also, change the sign. Is that okay? Change the sign here, change the sign here. That's the trick. So in changing the sign, my alpha is equal to -2, and then my beta is equal to, coming over here, if you change this sign, this is minus, if you change to plus. So you're going to have √5, just like that. No minus again, okay? This minus is just to tell us that this part will produce the imaginary part where you get your beta. My problem is solved. So it implies that y is equal to exponential alpha x a cos beta x, then plus b sine beta x. Therefore, the general solution of complementary function is exponential -2x, because alpha is -2, open bracket a cos beta is √5 times x plus b sine √5 times x. And this is my general solution, the complementary function. See, once again, I wasted time trying to do this because I have to show you how to work around the trick. Once you grab the trick, you don't need all these protocols showing. Is that okay? You can just go straight ahead and get a result. The next video, we're going to do that. On the board now, we want to look at another question. It happens to be a past question, 2014-2015, question 21. We are to solve 2 times second derivative of y plus 2 times first derivative of y plus 3y equal to 0. Note that these can be written as 2y prime prime plus 2 times y prime plus 3y equal to 0. And quickly we can pick out our word auxiliary equation from these homogeneous second order ODE. The auxiliary equation will give us 2m squared plus, take note here, the coefficient is now 2, then plus 2 times m, here the coefficient of the first derivative is also 2, plus 3y, okay, plus 3 equal to 0. Okay, so we've worked out this is the auxiliary equation. Now, we want to solve these and remember our trick. So I'm going to be very fast, okay? The complementary square method trick we're going to use to solve this. The first thing we're going to do is to remove these 2, make it to be 1, and that means I have to divide through by what? By 2. And once you're doing that, take note that this 3 has to be moved to the right hand side. Is that so? So let's do this, please. Let's do that. This is going to give us m squared plus m equal to -3 over 2. Is that okay? Good. We are going to find half the coefficient of this m. The coefficient of this m is 1. Half of 1 is 1 over 2. So that half, which is 1 over 2, I'm going to square it and add it to both sides of the equation. Remember our trick. So let's do that. Coming to the left hand side is going to be m plus 1 over 2, then everything squared, equal to -3 over 2 plus 1 over 2 all squared, right? And then this is going to give us m plus 1 over 2 all squared equal to, then if you work out these, we are going to get 5, that's -5 over 4. If you work out this, because this is 1 squared, giving you what? 1 divided by 2 squared will give you 4. So LCM of this, if you work it out, the LCM is 4. So that is going to be 4 divided by 2, which is 2. 2 times -3 will give us -6. 4 divided by 4, which we get from here, will give us 1. 1 times 1 is 1. -6 plus 1 will give us -5, all over 4, which is the LCM. Now, you know, ordinarily, I have gotten my alpha and beta. Must I take square root of both sides? No, it's not necessary. Now watch. From here, we get our alpha. From here, we get our beta. And then we see that alpha is equal to -half. And then beta is equal to, remember you're meant to take square root of both sides to remove this square. And if the square root covers this, you change this sign, which is minus to plus. So that's going to be square root of 5 over what? 4, which will give us beta to be square root of 5 all over. Square root of 4 will give us 2. My problem is as good as solved. This is incredible, right? So it will help you to get your result as fast can be. Let's conclude. The result of this is now y equal to exponential minus you know, it's exponential alpha x, and alpha is minus half, so minus half x, open bracket, a cos beta x, and our beta is root 5 over 2 times x, plus b sine beta, which is root 5 over 2x. And of course, this is the solution to this problem. This is GMAT 41. We are defined by integrity, commitment, and consistency. Always ready to deliver. Making learning fun, easy, homely, and targeted for you. And most importantly, convenient. Please like our videos and share them so that many more will learn. In others of our videos, we're going to see how you solve this generally. Is that okay? Following it step by step, both using the complete square method and using the quadratic formula. Of course, they're going to take your time, but just for you to learn them fully. Thank you.